Recently in one of my weekly live stream videos, I talked about this multi-part problem where one of the parts had to do with finding increasing and decreasing intervals of a function. And I thought you might find that part of that live stream video helpful, so I figured I'd make its own video about that topic. So in today's video, I'm going to be showing you a clip from that live stream actually where I talked about how to use the first derivative of a function in order to find the intervals where that function is increasing and decreasing. A lot of the steps that we're going to be going over in this video are covered on my free Calculus 1 study guide and my complete Calculus 1 package. If you want to check those out, there is a link to both of those things down in the description below. But without further ado, let's just go ahead and jump into the problem and I'll show you how to find the intervals of increase and decrease on a function. So really the first place you want to start when you're doing any of these problems is to start by taking the derivative of your function. So the derivative of this function can be found just by using the power rule. The power rule just says that, well, the derivative of a constant is just 0. The derivative of 3x is just going to be 3. And then the derivative of minus x cubed, we're going to bring the 3 down in front, bring the power down in front, and then subtract 1 from our power. So 3 minus 1 is 2. And then you're just going to leave your x as x. Okay, so there's our first derivative. Then, like I said, we're also going to need to use the second derivative. So we can go ahead and find the second derivative of our function. To find the second derivative of any function in general, all you have to do is just find the derivative of the first derivative. So the derivative of a constant 3 is 0, and then minus 3x squared can just be found with the power rule again. We're going to bring the 2 down in front, multiply it by the negative 3. So that gives us negative 6, and then leave the x as x, and then minus 1 from the power. 2 minus 1 is 1. X raised up to the first power is just x. So our second derivative is just going to be negative 6x. Okay, so now once we have our first and second derivative, there's going to be a kind of a few steps that we want to think about. So let's go ahead and start with finding our intervals of increasing and decreasing. That's generally going to be the easiest thing to start with, but both part A and B, where we're trying to find our intervals of increasing or decreasing, and find where we have local maximum and minimum values, those are both going to require us to find our critical numbers. So how do you find the critical number of a function? Well, all you have to do is take the derivative and set it equal to 0 and solve for x. So we already have our derivative. It's 3 minus 3x squared. So we're going to take 3 minus 3x squared, and we're going to set it equal to 0. And then the other thing we want to keep in mind, in general, when you're trying to find critical numbers, you would also need to figure out where does your derivative of your function not exist? Where does f prime does not exist? Which x values would cause that? Well, in this case, f prime is a polynomial. Polynomials exist for all x values. F prime, and f double prime are all polynomials, so we know that all three of these functions are going to exist for all x values. So this actually is not going to come into play here for our critical numbers. So we really just need to worry about where does our derivative equal 0. So to solve this, we can subtract 3 over to the other side, divide both sides by negative 3, and that gives us 1 equals x squared. Take the square root of both sides, and do be careful when you take the square root of both sides in an equation like this, you want to take the positive and negative square root. So we're going to get x equals the square root of 1 is 1, so we're going to get plus or minus 1. So we have two critical numbers, x equals 1, x equals negative 1. So now what we want to do to figure out where we have intervals of increasing and decreasing, we want to take these two critical numbers that we found and put them on a number line. So we're just going to start with a number line, and we're just going to draw our critical numbers on there. So negative 1 and positive 1. Okay. A common mistake I see people make with this sort of a problem is they will always put 0 on here. You don't want to always put 0 on your number line. You only put 0 on the number line if 0 is a critical number. In this case, it's not. So we do not want 0 on there. We only want to put our critical numbers on there. Once you do that, what you can do, and this is basically to use the first derivative test at this point, splitting your number line by the critical numbers is going to create different intervals. So you can see if you imagine this number line of all real numbers from negative infinity to positive infinity, we split it at x equals -1 and x equals 1. So basically what we just did was we created 3 intervals, right? We created an interval here, we created an interval in between these two numbers, and we created an interval over here. So what I like to do is just kind of think about what are the intervals that you just split your number line into. Well, we split it from -infinity up to -1. We split it from -1 up to +1, and we split it from +1 to +infinity. So we basically just created these 3 intervals by splitting our number line at our 2 critical numbers. Notice the edges of all these intervals are round parentheses rather than square brackets, because we don't want to actually include our critical numbers within these intervals. The reason for that is the critical numbers tell you where the derivative of your function equals 0. What that means is that is the point where f of x, the original function f of x, has a slope of 0, right? Because the derivative of a function tells you about the original function's slope. So if the derivative is 0 at -1 and 1, then the slope of f is 0 at those points. If a slope is 0, that means our function is not increasing or decreasing. So we don't want to include our critical numbers within our intervals. Now what we want to do is pick some numbers within each of these 3 intervals. It doesn't really matter what number you pick. You can pick whatever number you want, but it just has to be with one number within each of these 3 intervals. So let's just say we take -2, 0, and 2, because 2 is within this interval, 0 is within this one, and 2 is within this one. Now, basically what we can do is we can take those 3 numbers that we just came up with within each interval and plug it into f prime. Because again, f prime is going to tell us about the slope of f. So if we take these 3 numbers and plug them into f prime, the number that we get out is going to tell us what the slope of f is at that point. So if we know the slope of f is a certain number, that will tell us whether it's increasing or decreasing. Now, it's important to keep in mind, we don't actually care what specific number we get out of this. We just care if it's positive or negative. So f prime is 3 minus 3x squared. Let me just copy that down here. 3 minus 3x squared. Okay, so if we take -2 and plug that into this function, we would get 3 minus 3 times -2 squared, which -2 squared is 4, times -3 would be -12. 3 minus 12 is going to be -9. And again, it doesn't really matter that we got -9. What's important is that we got a negative number. So what that tells us is if f prime is negative, that means the slope of f is negative. If the slope of f is negative, that means it's going in this downward direction. That tells us that f of x is decreasing throughout this interval. So basically we know that the interval of -infinity to -1 is a decreasing interval. It is an interval of decrease. So that answers part of part A. We do still have to figure out these other 2 intervals now. So again, we're going to do the same thing. We're going to plug now 0 into f prime. So that's going to be 3 minus 3 times 0 squared. 0 squared is 0, times -3 is 0. 3 minus 0 is 3. So this is positive, which means f has a positive slope, which means f is increasing from -1 to 1. Okay, and then we're going to do the same thing with +2. 2 squared is 4, times -3 is -12, which again gives us -9. Negative slope for f within this interval means that we have a interval of decrease right here. So what that tells us is we have 3 intervals of increase or decrease. We have an interval of increase from -1 to 1. F is increasing from -1 to 1. And we have an interval of decrease from -infinity to -1 and from 1 to infinity. So increasing from -1 to 1 and decrease from -infinity to -1, and this little u just means the union. So basically these 2 intervals are both going to be intervals of decrease, basically intervals where our function is decreasing from 1 to infinity. Well, you made it to the end of the video. Thanks for sticking around to the end. If you want to see how the rest of this multi-part problem that I started in this video finishes, just go down below and hit that subscribe button and that bell icon so you're notified when I come out with that next video. If you are watching this video a bit after it came out, I'll come back and put it right over there as soon as it's out, so you can go check that out there. If you did get some value out of this video, do me a favor and hit that like button down below before you click on to something else for me though. It's a huge help to my channel so I can keep making more videos like this and so we can keep crushing it all term long in calculus. Thanks and see you next time.